So with 5.3, what have we looked at so far? We've looked at gaining some information or asking some questions about what's given in a graph, describing information that is given to us on a graph, and then now with example number 3, we are actually going to sketch a quick graph and then possibly describe, and then it says describe what's going on. So example 3, at the beginning of a race, Alicia took 2 seconds to reach a speed of 8 meters per second. She ran at approximately 8 meters per second for 12 seconds, then slowed to a stop in 2 seconds. Sketch a graph of the speed as a function of time. Label each section of your graph and explain what it represents. So this is key, this little information piece that they've given us here. Speed, graph of speed as a function of time. So that is telling us that this is the independent variable. And time normally is, but this is telling us it's the independent variable. Speed depends on this function of time. Okay, so it's dependent. So when we draw our graph, we have to have that independent variable on our horizontal axis. So just to sketch a graph, I'm going to put my 0, 0 point here, because I can draw nice straight lines now. There's that axis. This is going to be my time, so I label it time. What are my units? It's in seconds. What does my scale need to go from? Well, it needs to go from 0 up to a total of, how long does she actually run? She started at 2, so she needed 2 seconds to get to speed. She ran for another 12 seconds, and then she stopped in 2 seconds. So we need to go from 0 to at least 14. Okay, so we look at our grid, see, okay, well, we've got these lines here, 2, 4, 6, 8, 10, 12, 14. If I went up by 2s, then we would end up here. So I'm going to go 0, oops, wrong color, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Now a little bit further than I think we need to be, but that's okay. All right. So, oops. Now we look at the other, our speed. Our speed, again, if she's starting a race, has to start at 0, so that's a given. It's going to start at 0. This is going to be our vertical axis. It's going to run this way. And in a moment we'll figure out what we need it to the scale to look like, but we first need our label. It's our speed. We need our units, meters per second. And of course we need a title. What's the title for this graph? Being a race Alicia took and she ran. It could be called as simply as a graph of Alicia's run. It doesn't have to be a fancy title, just has to graph what it is. So now we look at the speed. She's going to start at 0. She gets up to a total or a maximum of 8 meters per second. Right here, 8 meters per second. And then slows down again. So our graph only really needs to go from 0 to 8. So let's see how we can fit this scale from 0 to 8 on here. If we go up by 2s, 8's only going to take us to here. And we've got all this extra space. 8's only going to take us to here if we go 2, 4, 6, 8. So we don't want to squish our graph too much. So let's expand those, and instead of going up by 2s, just go up by 1. So this would be 1, this would be 2, this would be 3, 4, 5, 6, 7, 8, 9, 10, just to give us a couple of extras. Okay, so there is our graph. Now I'll change colors because I can. Here we go. So she starts out at 0, and it takes her 2 seconds to reach a speed of 8 meters per second. So from 0 to 2 seconds in this time frame, she has to end up way up here. So we simply just draw a quick line from 0 up to there, As close as we can get it anyway. And there's our first section. She then slowed to a stop, and then she ran at approximately 8 meters per second for 12 more seconds. So from here, 12 seconds, her speed doesn't change, it stays the same. 2, 4, 6, 8, 10, 12 seconds. Hands up there. And then she slowed down to a stop in 2 seconds. Whoops, I missed. Missed again. Let's try this. There. So there's our graph of Alicia's run. And then we just have to describe what happens. Well, what happens from 0 to A? Whoops, that was bad. There we go. 0 to A, to B, and then to C. So from 0 to A, what happens? It takes her 2 seconds to reach a speed of 8 meters per second. And we are assuming that this is constant because we have a straight line. What's happening from A to B? She's constant speed. Speed is constant at 8 meters per second. For how long? For approximately 12 seconds. And B to C. So very simple explanations or descriptions of what's going on here. Slows to a stop. And it takes her about 2 seconds to do so. Very quick race for her. All over in 16 seconds. Yeah. So section 5.3 is looking at graphs, creating some simple graphs, describing them, answering questions about graphs that are given to you. You could have to draw your own graph and answer questions about it yourself, as well as I have a graphing assignment to help strengthen what you need to know what belongs on a graph every time. Okay? And I've touched on those already. You need labels with units. You need a scale. Sometimes the scale is difficult to find. You need a title. Oops, that's spelled wrong. You need a title. And then of course you need some points and dots and lines drawn. So you've got, I think I've got 4 graphs that you need to do. Otherwise, that's section 3, or section 5.3. And then 5.4 is just the graphing, so there's no notes per se for section 5.4. But prior to going into 5.4, we do need to talk about, or 5.5, we do need to talk about something that is called domain and range. So I'm going to have an extra video stuck in here just titled that. Domain and range just takes us into looking at equations and how we can write out domains and ranges for particular linear or for particular equations, depending on how the graph looks. Okay, so that's your homework. Feel free to get started now, or you could save it all for class.